Hello, I'm Andy Lomas and I'm the product manager for KATANA at the Foundry. So this is a new product that we've currently got in development. So to be clear, this isn't actually a release product yet, it's something we've got in development for release later this year. So this is a bit of a sneak preview about what KATANA is about. And KATANA is basically an application for look development and lighting for computer-generated images. But what it's specifically designed to be is an application for look development and lighting when you've got an asset-based workflow and you want to have incredible scalability and incredible flexibility. So first I'm going to talk a little bit about what I mean by an asset-based workflow. So what I'm talking about is when you get to almost like a level of complexity in the show doing 3D computer-generated imagery, where you basically need to start dividing things up into different tasks. So you have like modeling, lighting, animation, effects, people doing sort of set layout, basically various different people doing different tasks that then need to hand off sort of well-designed assets from one department to the next. So what KATANA's redesigned is for working in what we call the back-end pipeline for look development and lighting. And basically when you have an asset-based workflow, the look development and lighting often become the central hub department, so basically where all those 3D assets need to come together. And basically, so you've got all these different people producing these 3D assets, and they need to be assembled in look development and lighting, and then turned into things that can actually be delivered to a renderer. And this is basically what KATANA's about. So you have things like modeling, producing models, animation, producing what's often called geometric caches, which is basically, so you do the animation with rigs, and then you turn that into sort of cached data that basically shows how the surfaces are moving for every frame before sending it to lighting. Similarly from effects, you produce particle caches and volumetric caches. From tracking or layout, you produce camera data. So for live, if you're doing visual effects, it can be tracked off live action imagery. If you're doing CG feature animation, it's probably a layout department doing sort of like in the computer designing camera moves. But basically you've got all these different pieces of 3D scene data that need to be assembled together into lighting. And then in lighting, the process is that you often get sort of revisions and changes, so that you want to be able to edit and override anything in lighting. At lighting you need to create instances of shaders, assign shaders onto surfaces, create lights, move lights around. But also you get lots of potential changes that you want to make when responding to the needs of the director and visual effects supervisor. And this is basically what KATANA is designed to do. So a bit of the history of KATANA. The KATANA's actually been originally developed over at Sony Pictures Imageworks, and has been their core system for look development and lighting since 2004. So some examples of productions it's been used on include on the visual effects side, Beowulf, Spider-Man 3, Watchmen and Alice in Wonderland. And on CG feature films, Surf's Up and Cloudy with a Chance of Meatballs. So the big thing here is that basically visual effects and CG feature animation often have quite different production needs, but KATANA has basically responded to both those sets of needs. And also in the early days, when they were on Beowulf and Surf's Up, Sony were mainly using Pixar's RenderMan as their core production renderer. And then more recently, with Alice in Wonderland and Cloudy with a Chance of Meatballs, they've been using Arnold as their key production renderer. And KATANA's basically been able to respond to both of those as well. So it's basically responding in a variety of different sort of production environments, effectively, and a variety of different renderers, as well as dedicated in-house renderers they use at Sony. Now I'm going to talk about some of the real-world production problems that KATANA helps solve. In some ways, this is the core of KATANA, that has come from real practical production needs that went at Sony. So the first one is, how do you update assets once a shot's already in progress? When you're doing sort of basically a large-scale production, you want to start lighting and look development as soon as possible, before assets are complete. In fact, you never really know when an asset is complete until the end of the show, because there could be requests for updates or revisions to it at any point. But how do you start lighting early, but then be able to update assets coming through into lighting without having the real problems about having to redo lighting or being a really difficult process how to actually rebuild lighting shots? Also, how do you share data between shots? That a lot of the things you want to do aren't necessarily just on like a one-shot level of granularity. You might have lighting rigs that you want to share across a sequence, or edits or overrides you want to put across multiple shots for the effect stuff. So basically, how can I work both on like the individual shot level, as well as asset level, as well as multiple asset level, as well as multiple shot, multiple sequence level? Also, how do I avoid huge number of shot-specific asset variants? And this is in some ways one of the potential dangers of an asset-based workflow. But as you start getting like lots of requests from the director or visual effects supervisor saying, for this shot, could you change this? For this shot, no, I want to make that window more reflective so I can see Spider-Man more clear in that window. Or I want to sort of, tweak that model for this one shot because it doesn't compose quite right for the camera. One of the dangers is that you can end up with very, very, very large numbers of shot-specific variants of assets, or sequence-specific variants of assets. So one of the ideas in KATANA is that you can make new variants of assets if you really want to, but if you've got a recipe that describes all the things you want to change for lighting, that you can do, if you can do things in the recipe instead of actually just making a real new asset variant, you potentially can massively reduce the number of asset variants. So basically you've got the choice in production to say, actually this change is just part of the recipe. I want to keep to the original asset, and when it goes through this recipe before being sent to the renderer, that is how the asset variant, the change that's needed for this shot is made. Also, this can really help the process of updating assets coming through the pipeline. That if I've say got the Empire State Building, and I've got to change the Empire State Building needed for this specific shot, if that change is just remembered as a non-destructive recipe change, then all I need to do is update the original Empire State Building, and the shots that need the changed version will just sort of pick up that change automatically, rather than having to worry about, like, once I make a new version of the Empire State Building, what other asset variants do I need to update as well? Next one is how to use multiple renderers. That you may have good technical reasons why you want to use different renderers for different passes, different parts of your production. So you might have a scanline renderer do for most of your rendering, but I want to do a global illumination bake in a ray tracer, or I've got a specialist particle renderer or a volumetric renderer. So how do I mix different renderers together but have a consistent workflow working all those different renderers? Also, a lot of pipelines get built around the specific features of one renderer. I mean, some renderers, particularly RenderMan. RenderMan has lots of very, very pipeline-friendly features about how you can do things like set attribute inheritance, so that how you can set overrides for particular objects, for shaders and things like that. How attributes can inherit down the world hierarchy, which is great for building a pipeline, but there's also a danger that if you build your whole pipeline around the features of one renderer, it's very difficult then if you want to use another renderer for specialist purposes, or if you want to switch to using a different renderer. So how can I have a consistent workflow and consistent way of setting things up and be able to make use of good pipeline features for multiple renderers? And KATANA is designed so that, in principle, any shader-based renderer can be integrated and basically use KATANA as the interface for setting things up for presenting to the renderer. And also, the final one I've got here is probably one of the main reasons behind the original development of KATANA at Sony, is potentially how do I deal with potentially unlimited levels of complexity. So when you're doing shows at Sony, such as getting into Spider-Man 3, where they potentially got the whole of New York they may want to treat as an asset. So you've got all those buildings, but also got Spider-Man, I've got debris destruction, I've got cars, people, potentially even like Central Park with every tree and every leaf of every tree in Central Park. How do I deal with assets of that size but still be able to do look development and lighting on them? As well as how can I still have that flexibility to be able to manipulate anything, so that when the director says that one little leaf on that tree is too green for some reason and I want you to change change the look of that, I still can drill right down to that individual thing and make the change to that. So this is the really, really key thing, is how do I have that scalability, but with the scalability also get incredible flexibility about how can I actually do the things that I need to do as a lighter in a shot. So now I'm going to switch to actually showing KATANA running live to sort of illustrate how KATANA actually solves some of these problems. So the first thing to notice is that the interface in KATANA looks in many ways much more like a node-based compositing package than most 3D applications. And this is really very deliberate, that in some ways when you think of what you're doing in node-based compositing, it's almost like designing a recipe. That you have your file in saying bring these image sequences in, then various non-destructive processes saying like blur this, composite this over this, and then going out to potentially totally independent different outputs for writing files out. And you can update the image sequences relatively seamlessly. So I've got a new image sequence that I now need to run through my comp. Your comp is still effectively a rule-based, recipe-based thing to describe how to produce everything. And this is exactly basically the principle that KATANA is based on, is that basically if we try to treat look development and lighting in a recipe-based approach, almost just like node-based compositing, that's almost like a much more sane way of getting almost a separation of I've got assets and I've got my recipe. And I can update my assets and my recipe should still work with those updated assets. And I can start my recipe before I have all my assets ready. So basically, you almost like have a sensible separation when you're doing pipelines, so you can work in parallel between assets and recipe. Okay, so the top here I've got a node which is going to bring in a whole set of geometry. So almost like this is putting the file in, but what it's going to bring is a whole set of 3D geometry assets. And these are actual real production assets from Sony of some of the buildings they've used it in New York, in Spider-Man 3 and Watchmen. So basically this node says bring in a hierarchy. And I can basically, if I close my hierarchy down, all I get is a bounding box. At this point, all Katana needs to know is I've just got a bounding box. And then I can sort of open that up and I can see the buildings inside that. And one of the principles here is that to light a shot, you don't really have to load the whole of that scene data into the lighting application. It's the renderer that needs to be able to see all the geometry. For lighting, most of the time, all I need to see is relatively low proxy resolution versions of things, so I can direct my lights in the right directions, so I can set things up. But I still want the flexibility to be able to open up anything if I really want to. That's also my really strong principle of Katana, is I really do not need to load my whole scene into the computer to actually light it. So hopefully for most lighting this is enough. I can just have proxy representations of things, then I can create lights, work out where those lights are pointing at. And then when I send it to the renderer, and this is up here I'm actually seeing a genuine RenderMan render. It's the renderer that needs to be able to take my recipe and then load all the proper geometry it needs. But I still want to be able to drill down into anything if I want to. So in here I absolutely can just drill right down into any asset, right down to individual pieces of geometry if I want to. If there's some reason that I need to go into that piece of geometry and change an attribute, change a parameter. In fact, in Katana I can get even right down to having a look at all the vertex data, all the UV sets. All that information is still available to me if I want to be able to edit, modify that and inspect that. So now here I've got some other nodes, so a node creating a camera. And basically you can see it's also very much like a node-based compositor, that I get the parameters for the node, and I can I can click on a node and see the parameters at the node. I also can click on a node to see the view at that node. So if I click on this node, it shows the 3D scene that's produced in my node graph at this point. So at this node, what I get is a small scene with the camera. This node is creating an instance of a shader. And in this case, I'm creating a RenderMan shader, and so here I get what shader I want, and basically I can dial parameters of a shader. And here's another instance of a shader designed for doing window materials. And then I have lots of non-destructive processes that I can basically use to affect the scene. So I've got things that can combine different parts of those scene elements together to create a single scene. And here I've got a node that basically can assign materials to objects in my scene. And these are all done using non-destructive rule-based approaches. So for instance here I've got a rule saying I want to assign my window material onto everything that's got the name glass in the object names. So if I've got very strong naming conventions, I can set up things like material assignment based on naming conventions. And there's all sorts of other ways you can do it. Basically, Katana is a very flexible tool set, effectively. So I also could do material assignment based on metadata. If there's a piece of, a given named piece of metadata in an object, then I want to have this material. Or based on the values of metadata. Or also what's called collections, basically arbitrary sets. So that, say, in modeling, I can be saying, whenever I've got a stainless steel object, I want to add that to the set of stainless steel objects. So as I get downstream in look development and lighting, I can just say, put the stainless steel shader on all stainless steel objects. But as you can see, it's like really powerful tools for setting things up in this rule-based way. Then here I've got a node which is almost like the sort of one-stop shop for creating lights and dialing shader values. So in here I can sort of create lights. I can do things like mute lights, so I can, for interactive rendering, switch off the effect of that light. Solo a light, just so all I can now see for the next interactive render is just the effect of the light. What shader it uses, the main parameters, so the color of the shader, intensity of the shader, whether exposure offsets, which are the main things that most lighters need to sort of change around. But if I want to dial right down into the individual shader settings, I can still open up all the original, these are RenderMan shader settings that the shader had. So what I'm going to show is basically, I'm going to now show you some rendering. Now this is going to be using Pixar RenderMan's Lumiere, which is basically the interactive relighter for RenderMan. So before this session, I rendered what's called a Lumiere cache. It took about 5 or 6 minutes to take this real production geometry with real production textures and sort of create the first image. But once I've got the cache, I can then move lights around interactively to see updates. So first of all, I can do things like look through a light. If I go to my gaffer mode, okay, so back to my gaffer node. and I can sort of go to a light, look through that light, and move that light around. And then you can see that basically I get this much faster than doing a full re-render update. So this is basically Katana just acting as an interface to a renderer that has interactive relighting capabilities. So renderers like RenderMan and Arnold and things like that have interactive relighting capabilities. This can act as an interface. So I can move the light around, I can say change the colour of that key light. Say I want to do a more nighttime scene and I wanted to make the key light a sort of redder colour. Then also I can maybe let's take the backlight and change the colour. Let's change the intensity of the backlight slightly. So let's change that down to an intensity of 1.5 rather than an intensity of 2. Or I can go to my spotlight that's got the Hieronymus, who's our logo from the Foundry. Hit my spotlight, look through that, and get up some geo manipulators for that and change the spotlight. So I can make the spotlight bigger, move the spotlight around, change the hardness on the spotlight. Let's move back so I can see Hieronymus's face. Now, Hieronymus has probably been partying at NAB a bit too much, so let's make Hieronymus green. So really saying this is Katana can act as an interface into a renderer's native capabilities. And then down at the bottom here, I've got like a number of different render outputs. I've got, saying that down this branch I want to configure things for my main render, but down this pass I want to configure things for my specular pass. So I can do things like edit-based changes to say things like how I make a specular pass is I take every shader in my scene and I want to override the diffuse value to dial that down to 0. And basically, I can have almost like arbitrary amounts of nodes, very much like a 2D node-based comp, to say how I individually want to tailor things. And if an individual mod object needs to almost like special attention for how it needs to be configured for render pass, I can define that in nodes. Okay, now I'd like to talk about the work we're doing at the Foundry with Katana. So basically we're working on what we're calling a technology sharing agreement with Sony. So basically they're continuing development on Katana, we're continuing development on Katana, and basically we're collaborating together to turn Katana into something hopefully as an industry standard to be used by everyone outside Sony as well. So it's in development for release this year, and it's already in a limited release alpha test with a number of different studios, including Moving Picture Company and Digital Domain. We're also already making use of Katana technology in other products at the Foundry, which is one of the things we're really excited about. But it's something you're probably not going to see so much as users directly, apart from there probably going to be really interesting ways that we can share 3D information between different products at the Foundry by things using the core libraries that Katana is built on in the products of the Foundry. And we're already making use of this in Nuke, so the way we're getting from Nuke to RenderMan is actually using Katana libraries internally. And that worked really, really well. And we're already now looking at making use of that in Mari and having much, much richer links between different products of the Foundry, making use of Katana technology. And finally, I'd also just like to say that we've also got a white paper about Katana. So if you're interested in finding out more technical information about Katana, we've got a white paper on our website which goes into a lot of the real concepts behind Katana. So if you're looking at what might be involved in integrating Katana into a pipeline or putting a new renderer into Katana, the white paper on our website gives a lot of the real core information about the concepts and principles that Katana is built on. Thank you.